So the easiest way to get .NET code into your AWS environment in a way that's going to be native and easily understood by you is to use a virtual machine. Now, as you know, for a virtual machine to work, and this is also the same in Azure, you have to have it sitting inside of a virtual network. So we'll call this a VNet. And VNets are typically partitioned into subnetworks called subnets, right? So inside of a VNet, you might have one or two subnets, okay? And VMs themselves would typically have what's called a public IP address. So put it here, public IP, which sounds like it's just an IP address, but it's really not. It really is an appliance of some sort that maps the IP address that's exposed externally to the outside world to a NIC, a network interface card that's sitting inside of your VM, such that when traffic comes from the outside world, it the traffic addresses the public IP address, and then that basically routes that traffic to your VM. And then inside of there, you have things like network security groups in here that you can use as a rudimentary firewall. And then you can also put a firewall actually at the VNet level. So there's a bunch of things that you can do. So in AWS, this structure is somewhat different. What would typically be referred to as a VM in AWS is called an EC2. So we'll be creating an EC2. And EC2s are placed into what I guess you could refer to as a VNet, but it really provides a lot of different things besides that. But something called a virtual private cloud, or VPC for short. Okay. And inside of the VPC, you continue to have this notion of a subnet. And you also have this idea of a public IP. In this case, they're called elastic public IPs. Now, both of these technologies both have this notion of route tables. And route tables basically specify how you route traffic in and out of your subnet. So this guy also has a route table. The route table is a way that you can control, for instance, if you want to make your traffic leaving your subnet in Azure go to some kind of network appliance, you can specify what the next hop is in your route table, and it will route there. In the case of AWS, these public IPs are not inherently exposed. Even when you specify a public IP, it's not inherently exposed and just there. For you to actually get everything working, you do need a gateway, network gateway. Okay, and then this gateway basically serves as the next hop or serves as a route for your route table. And then when that route is there, then you would normally access your access over the elastic public IP, and then it will make its way to your EC2. So what we're going to do in this video is we're going to create a basic server application. And this server application is just going to be an HTTP listener that can respond back. We're going to set up this virtual private cloud, set up the subnet, set up the EC2, copy our server in there, and then demonstrate basically being able to make a call to the server from inside of AWS. Let's get going. So to get started, because I'm going to be testing this locally, I'm actually going to create a Visual Studio instance that has admin privileges, and I'm going to be creating a basic console application. Why don't we call it AWS server? And we're going to use .NET 9 For now, we won't do containers. Containers is another way that you can do this. But for now, we're just going to do it this way. And over here, I'm actually going to use the new namespace terminology. And for you to be able to use an HTTP listener, you do need to have system.net enabled. So we're going to add, right? And so in here, we're not going to need this. So let's just quickly copy over the code that we're going to be using. So this code basically creates an HTTP listener as the prefix, in which case we're using star here because we're saying that, hey, this is any URL that connects here we want to use. And then we're going to have a while statement that basically does the actual processing. And so this while statement basically does something pretty straightforward. We get the context from the listener. We get the query string called message. We write the query string to the console, and then we just create the response by basically setting the content type to text, setting the status code to 200, and then writing you said whatever to the output stream. Now, in this case, this output stream, there's red squigglies here because it's saying write string. And there is no such method as write string, but write string is an extension method that we're going to use so we don't have to keep converting strings into bytes and bytes back into strings. In our code, we just do it once. So I'm just going to copy paste the code in here. We just have a stream extension, and write string basically extends stream. You pass a message in, it encodes it as ASCII, converts it to data, writes it to the data, and then just flushes. So for any stream, you can quickly use this to write to the source of that, the actual underlying stream, and flush that. And then once we're done, we check the message. If the message that was sent was end, we basically break, and that's the end of the code. That's pretty much it. So let's build this and let's just test it locally first of all. Make sure that it works. So it looks like it started fine. So we can now basically open up a new window. I'll drag this over here and we can do HTTP local host. And we don't care what it is. So let's call it. And the query string we're looking for is message, but the prefix is hello. And so the query string of message equals test 1, 2, 3. Then we hit enter. It basically says you said test 1, 2, 3, and over here we can see test 1, 2, 3. Okay, so let's make it a little bit more formal because this doesn't look quite right. Since we are echoing what the user has sent, we'll change this to say echo. And in here we'll put a colon so it's clear that it's reading. And then over here we will also kind of just clean up a bit and say there we go. So that's cool enough. So the next thing we're going to do is we're going to build and publish this so that we have this running and we can test it. So first thing I'm going to do is I'm going to make sure that this is doing AOT compilation. AOT is ahead of time compilation. Okay, this is all just to make the compilation size smaller. And then we're going to publish. And I want to publish to a folder. Okay, so we got that done. Now we're going to open up this thing that says show all settings. And we're going to switch this over to actually x86. And because we're using, and then we're also going to make it self-contained. And in here, we are going to produce a single file. So we just want everything that we need, want to trim everything we don't need out, and just create a single file that can do what we're looking to do. So let's publish this bad boy. Okay, now on Windows, you do need to um, be running an admin. So now that this is published, let's go ahead and let's just take this URL here, and we're gonna open another admin terminal so we can run this in the terminal. Actually, before we do that, let's give some kind of indication that the code that the server has started. Okay, so okay, so we'll just publish this again. Let's copy this guy, and we're gonna go here and we're gonna run it as admin. And we're going to cd here, and then we'll run the AWS test server. And there we see that it started. And let's go back here, and we can do test 1, 2, 3, 4, I guess. Oh, well, that's not going to work because we switched it to echo. So let's change it to echo. And there we see we have user message test 1, 2, 3, 4 and test 1, 2, 3, 4. So our server is done. Now let's switch over to AWS and let's configure the environment that this server is going to live inside of this .NET code. So the easiest way to get into your Amazon console is to go to console.aws.com, .aws.amazon.com, and that's going to auto sign you in if you already have a subscription set up. If you don't, then you just have to go through and create one. And the first thing we're going to do is we're going to create the environment that our VM is going to sit in. So we simply go over to this networking. And if you scroll down to the bottom, you'll see VPC. And to set it as a favorite, we can just click that. Then it'll show up in the top bar here. So you see VPC. So let's go ahead and let's now create a new VPC. And we're going to start from scratch. So we're going to do VPC only. There is VPC and more, which will configure everything for you. And when you get in here and you're doing your own thing, then I would suggest you do that. But in this case, we'll create our own. So I'm just going to call it VPC server 1, or actually, let's call it AWS server. So in this case, we're setting the CIDR range to .1, and then we have a /24. So let's go ahead and let's create this. And with that created, you see this resource map, which basically shows the VPC, the subnets, the route tables. So route table is created by default on this, right? So we can go into this route table and just, actually we can go here and we'll just name it RT AWS server. So the next thing we can do is we can create a subnet for this. And so we'll just create the subnet. And this subnet is for the VPC AWS server. And we're going to call it so we're just using the same thing. This does have availability zones and whatnot. And 10.0.1.0. So we'll put this in the /28, which is 16 IP addresses. And a lot of what we're doing here is, you're going to be doing it in script, but it's just illustrating the basic flow. So now, if we go back to our VPC, you'll see that we have this flow here, this resource map, which does have the route table, does have the server, but we don't have any network connection. So let's say we now add our VM because we're done creating our VPC. So we go over and we click on here and we go to compute, and now we want an EC2, which is a virtual server in the cloud. So we click on that. And over here, I'm going to make set all states to running so we can clear it up a bit. So to create your VM, unlike in Azure where it actually has the create, in this case, it says launch instances. So that's how you create it. So we'll call it AWS server host. So this is the host for the AWS server. We're going to use Windows. And instance type, we'll use a T3 extra large here. T3 micro, medium, large. So this has 8 gigs of memory. Yeah, large should be fine. And here to connect to your server, you basically can use a key pair. You can create a new key pair, in which case it'll just download it to you. And this is the key pair that will be used to encrypt and decrypt your passwords if you're accessing it over RDP, which we will be doing. So we're going to do a PEM. So we call it AWS server key. AWS server, and we just create the key pair. You can see it's downloaded it right there. So that's pretty much all you have to do there. For network, we're going to have to edit this because we want to use our VPC, which is AWS server. I want to use our subnet. We want to auto assign IP addresses. So I'm just going to enable that. All right, so it looks like that is built out. And if we refresh this now, we should have the AWS host, and it is running. And it does have a private IP, and it does have a public IP address. So let's try connecting to it and see if this has been fully requisitioned. Looks like it has. So if I click on download remote file, it should download this guy. And when I try to connect, we should note that it's not connecting. It's not instantaneously connecting, and this should connect easily. Why is that? Well, this is because we have not connected this to the outside world, right? So we don't have the network gateway specified. So let's go back to the VPC, and we can go over to the internet gateway, and let's add a new internet gateway. So and that creates one. And then now let us attach it to our VPC AWS server. So when we now look at this map for AWS server, we now see that this VPC exists, but we still note that we don't have a connection between the route table and that. So let's go ahead and let's create that connection. So for this route table, we're basically going to add a new route, and we're routing to the internet 0.0.0, and we're going to specify internet gateway, and the gateway we want is the gateway AWS server that we just created. Let's save that, and let's now go back over to our VPCs, and let's take a look at this. And now you should see that we do have a full connection all the way through, and this guy is actually green now. So with that specified, let's see what happens with this AWS host file now when we try to connect to it. There. See, now we're getting a connection because the route is passing all the way through. But of course, we now need the password for this. So the way we get the password is in our EC2 instance. When we click on connect and go to the RDP client, you see it says here get password. Well, there's two ways we can paste the private key content here and decrypt it, or we can upload the private key file. This is the key file that we created before. There it is, key AWS server.pem. And when we do that, it actually puts the private key in there. Then we decrypt the password, and it gives us our password, which we have here, which we can then take over here and paste. And when we say OK, see we're good. Not going to ask again. And we are connected. So we'll let that set up. And while it's setting up, let's go back here. And we're basically going to copy our AWS server code, which, by the way, is only 2.6 meg. Let's copy that. And it looks like this is done. So we're going to paste it in here. Go to this PC. And we'll just create a folder named server. And let's go ahead and let's paste that there. Okay. Now, one thing to note is that Windows machines do have a default firewall that's built into them. So for the purposes of this demonstration, we will disable that. So I'm just going to find Defender. And I'm just going to turn it off for now. Let's say OK. So that's turned off. AWS server is set up. Next thing we want to do is we want to start it. And remember, we're going to be running it in administrator. So let's do that. And then let's go to that directory. And then let's run AWS server.exe. And it looks like it started. So as you can see, if we run it locally, we get a response. And it does say user message test. So that's working. So now that we have everything connected and we have our gateway set up, we've gone through and we've um, disabled the Windows firewall. We have our server running on our VM or our EC2. There is one more thing that we do need to do. We do need to go and make sure that our security group that we're using, which is the Launch Wizard 2 security group, I believe, has all the appropriate things configured for inbound rules. So in Azure, these are called NSGs, network security groups. They just call them security groups here, but essentially they function the same way in that they allow for inbound and outbound traffic. So right now, this subnet that we have is only allowing RDP. And for it to allow more, we basically need to add it. So let's edit our inbound rules. And we're going to add HTTP. And we want to make sure that we're adding it for coming from anywhere. And then we're also going to add HTTPS. And again, we want that coming from anywhere. So with that done, we save these rules. And that should give us those permissions that we're looking for. So with this connected, we should now be able to go to our URL. And as you can see, that is working. And I can change this to say anything and it will work. And of course, if I make it say end, and at that point, if I make it say anything else, basically it'll go on forever because the server has been shut down. So this has been a basic explanation of taking your .NET code and hosting it inside of AWS. Again, it's the most basic form of it, which is just taking it and deploying it directly into a VM that's running inside of the AWS environment. In future videos, we will show you basically ways to take your VM and host them as Lambdas, host them in containers, and all the other cool things that you can do with .NET inside of AWS. Like and subscribe if you enjoy our content. Hope to see you next time. And as always, we who are about to code salute you.